Hello everyone, in this video lesson, I'm going to discuss about ideal gas law. So you've learned about the different gas laws such as Boyle's law, Charles law, Avogadro's law, and Gay-Lussac's law. So not all the time, okay, like for example, yung amount of gas or yung number of gas constant or yung pressure or the temperature, okay, or volume of gas constant. So what will happen if these quantities or properties of gases hindi constant or nagbabago. Okay, so that can be explained by the ideal gas law. So what do we mean by ideal gas first? So when we say ideal gas, it exhibits no attractive forces between particles. Okay, and in the ideal gas law, which can be presented in equation form, both pressure and volume are directly proportional to temperature. Okay, and to explain further ideal gas law, we have the universal gas constant. Okay, so that's the only variable that is constant for the ideal gas law equation. Okay, so I have here our assimilation. Okay, that can show you possible things that could happen kapag nagbabago yung number of gas molecules, nagbago yung temperature, nagbago yung pressure, and even the volume, nagbago din. Okay, so let's say for example, okay, let's have this container, and let's say for example, increase natin yung number of gas. No? Increase natin yung number of gas or amount of gas inside this container, and watch what will happen dito sa ating temperature. Naka-Kelvin yung ating temperature dito sa ating pressure. As of this moment, 0. Okay? So watch what will happen also dito sa ating container. Okay? So let's increase the amount of gas. And as you can see, habang nag-increase yung number of gas, nag-increase din ang pressure at nag-increase din ang temperature. Okay? And if we change the volume also, look, if we increase the volume, okay, tingnan nyo ang nangyayari sa pressure. Pressure is decreasing, temperature is also decreasing. But if we decrease the volume, okay, tingnan nyo ang nangyayari sa pressure. Pressure is increasing, temperature is also increasing. Okay? Or if we add more, okay, amount of gas, okay, pressure is increasing, temperature is also increasing, and then, so ang nangyari, hindi na nakaya ng container natin, okay, it can no longer hold on doon sa force na ini-exert ng mga gas molecules inside this container. Okay? Alright, so when we say ideal gas law, we mean combining of all previous relationships into one equation. So again, we have our different gas laws here. Okay, we have Boyle's law, okay, which shows you the relationship between pressure and volume of a gas at constant temperature and fixed amount of gas. So there's an inverse relationship now between the volume, okay, and pressure, okay, for Boyle's law. For Charles law naman, there is a directly proportional relationship of volume, okay, and temperature at constant pressure and amount of gas. Same also for Gay-Lussac's law, okay. For Gay-Lussac's law, pressure is, of course, directly proportional to temperature, again, at constant volume naman, and of course, amount of gas. And for Avogadro's law, okay, volume is proportional or directly proportional to the number or amount of gas, this time at constant temperature and of course, pressure. Now, if you're going to combine all these gas laws, what we have would be the ideal gas law equation. So again, we can actually use any of relationship that we have here so that we can derive the ideal gas law equation. So if you still remember, okay, let's use this one here. Okay, so we have pressure is inversely proportional, okay, directly proportional to K constant, which is, of course, for Boyle's law, this is temperature and amount of gas, but inversely proportional to volume of a gas. So if we can rewrite this, this would look like pressure is equal to temperature, okay, times the amount of gas, which is represented by N, and of course, we have our universal gas constant, which is represented by R, okay, and then over the volume, okay. So if we can rearrange this, it will look like pressure times volume is equal to the amount of gas in moles times the universal gas constant and the temperature in Kelvin. So this is now our ideal gas law equation, which we can use to know what will happen or what will be the value of pressure, volume, or the amount of gas, or the temperature, and of course using the universal gas constant. So we have here our universal gas constant, which is equal to 0.0821 liters atmosphere per mole Kelvin. Ito, nag-iiba yung unit ng universal gas constant depende kung ano yung ginamit na units sa ating mga different properties of gases. So I'm going to show you how this universal gas constant can be calculated, okay, at STP, standard temperature and pressure. So anyway, this is our ideal gas law equation. Now, to calculate this, okay, using this, so let's have here at STP. So when we say at STP, ano ba yung value ng temperature, pressure, at volume ng gas sa isang mole? 1 mole. So, okay, first we have the number of gas muna. Okay? The number of gas, let's say for example, we have 1 mole. Okay, 1 mole of gas. And for 1 mole of gas at STP, okay, let's have the temperature. The temperature is equal to 273, okay, 0.15 Kelvin at STP, okay, and of course the pressure is equal to 1 atmosphere. Let's use this as our unit for pressure, 1 atmosphere, and of course at STP, at standard temperature and pressure, the volume of a gas is equal to 22.4 liters. Okay, so from this, we can calculate the universal gas constant. So let's derive the equation from this. So we have now, okay, universal gas constant is equal to, okay, pressure times volume over the number of gas, okay, and times temperature. Now, we can substitute now our known values here. So, meron tayong pressure, which is 1 atmosphere. So, definitely, walang makakancel dito na unit. Okay, 1 atmosphere times the volume, which is 22.4 liters for 1 mole of an ideal gas, over 1 mole, okay, times the temperature in Kelvin, which is 273.15. In some books or in some, they use 273. Okay, pwede din 273.15 Kelvin. Anyway, the more significant digits, the more accurate or precise. So we have here now 1 times 22.4, that's simply 22.4. And of course, 1 times 273.15, that is simply 273.15. So, pag divide natin yan, so we have here 22.4 divided by 273.15. So, we have universal gas constant in these units, no? We have 0.0 8 to 0, 0, 6 to 2. So, sinulat ko lahat yung given. So, that our unit would be atmosphere, okay, liters per mole, and then Kelvin. So, ito na ngayon yung ating universal gas constant. So, ito din yun. Okay, here naman kasi ang ginamit nila is 273 Kelvin. Okay? So, ito naman ginamit kasi natin dito ay 273.15 Kelvin. So, you don't need to memorize this as long as you know the number of gas, which is 1 mole, the pressure, okay, which is 1 atmosphere here, and for the temperature, 273.15, and of course, the volume of a gas at STP, which is 22.4 liters, you can always calculate, okay, the universal gas constant in this unit. Okay, if ito yung ginamit natin na units sa ating mga given. Here's a problem. So, at what temperature would 2.10 moles of nitrogen gas have a pressure of 1.25 atmosphere and in a 25.0 liters tank? So, ito yung given natin. Meron tayong volume, which is 25.0 liters. Meron tayong pressure, 1.25 atmosphere. Number of moles of nitrogen is 2.10. At of course, gagamitin natin yung universal gas constant at ito yung unit niya. Okay? Kasi kung titignan natin yung given natin, yung unit ng ating volume liters, yung pressure natin naka-atmosphere, at yung, of course, yung number or amount of gas naka-moles. Okay? So, yung unit ng ating temperature we expect ay in Kelvin. So, that's why ito yung gagamitin nating value ng universal gas constant natin. So, depende sa given. Okay? Kung ano yung gagamitin mong unit ng universal gas constant. Now, we know that we will be using the ideal gas law equation, this one here, because in this problem, it's very clear na hindi constant itong mga properties, yung mga volume, pressure, and amount of gas. So that's why this is the appropriate gas law equation na gamitin, yung ideal gas law equation. So since ang hinahanap natin is yung temperature, magdi-derive tayo ngayon. So we have pressure times volume is equal to, okay, amount of gas, the universal gas constant, and of course, temperature. So, gagawin lang natin to. Okay, itong universal gas constant, okay, ito N, and the amount of gas, which is N, and the universal gas constant, ilagay natin dito sa baba ng pressure and volume so that we have the derived equation. So, we can say that temperature of nitrogen gas in Kelvin is equal to pressure times volume over the amount of gas in moles times the universal gas constant. Okay, so we can now substitute the values here. So we have pressure is 1.25, okay, atmosphere, times the volume, which is 25.0 liters. Okay, 25.0 liters. And of course, over 2.10 moles, okay, times the universal gas constant, okay, which is 0.0821 liters atmosphere over mole Kelvin. So, alam nyo na kung ano yung mga units na maka-cancel dito. Okay, so, definitely maka-cancel yung ating unit sa pressure. Okay, yung unit sa volume. And of course, yung unit na moles. So, matitira lang ay yung unit ng ating temperature, which is Kelvin. Okay, so let's now get the product and the ratio of this. Okay, so 1.25 times 25.0, that is equal to our that is equal to 31, okay, 0.25 over, let's multiply this. Multiply natin itong dalawang to. Okay, so this is equal to 0.17241. Okay, so kunin natin yung ratio nila, 31.25 divided by 0.17241. That is, okay, so our temperature in Kelvin is equal to 181, okay, Kelvin. Okay, so ito ngayon yung ating temperature. Okay, so here's another problem. Here, determine the volume of occupied by 2.34 grams of carbon dioxide gas at STP, standard temperature and pressure. So for this problem, these are the known. So we have the amount of gas, but this time it's in grams, not in moles. So 2.34 grams of carbon dioxide. So since it's at STP, so yung pressure natin dito is 1 atmosphere. Yung ating temperature is 273.15 Kelvin. And of course, we will be using this universal gas constant. And of course, our problem is we need to find the volume, okay, the volume of the gas. And of course, our equation is, of course, we will use this. But before we use this equation, we have to convert first the amount of gas from grams to moles. Okay, so if you still remember our lesson in Avogadro's law, okay, so i-convert natin muna si amount of gas sa moles. So remember, kailangan nating kunin muna yung molar mass ng carbon dioxide. So first, let's find the molar mass of carbon dioxide. So if you're going to check your periodic table of elements, so if we have our carbon here, okay, for the molar mass of carbon dioxide, we have 1, okay, times the atomic mass of carbon dioxide, which is 12. Okay, so ibig sabihin 1 times 12, that's 12 gram per mole. And then for the oxygen, okay, meron tayong dalawang oxygen dito, and we multiply that to its atomic mass. So the atomic mass of oxygen is 16. So 2 times 16, that's 32. Okay, so we get the total of this. So 12 plus 32, that gives us 44. Okay, so the molar mass of carbon dioxide, or 1 molecule of carbon dioxide, is equal to 44 grams per mole. Okay, so gagamitin natin ngayon. So number of gas in moles is equal to the mass of the gas or the substance in grams over the molar mass. Okay, so we will be substituting now. So we have 2.34 okay, grams of carbon dioxide, and for that amount of carbon dioxide, the molar mass, okay, per mole is equal to 44. Okay, 44 grams per mole. Okay, so makakancel yung grams na unit. So 2.34 grams divided by 44 grams, our amount of gas in moles is equal to 0.05 moles. Okay? So since na-convert na natin yung ating amount of gas from grams to mole, we can now substitute it here in our equation. But first, mag-derive muna tayo. So we have here, okay, since we're looking for the volume, so volume is equal to amount of gas in moles times the universal gas constant times the temperature over pressure. Okay, so let's substitute now. Okay, so substituting the values in our derived equation, so we have here our amount of gas in moles, 0.05 moles times 0.0821, our universal gas constant, times the temperature at STP, 273.15, divided by 1 atmosphere. So we don't have any problem here kasi 1 atmosphere naman. So let's just get the product here. Okay. Okay, so if we get the product here, 0.05 times the universal gas constant, 273.15, and then divided by 1.0 atmosphere, our volume is equal to 1.1. Okay, our unit is liters. So definitely na-cancel yung unit na moles, yung atmosphere, okay, and of course yung unit na Kelvin din. So, ang natirang unit is yung unit for volume, which is liter. So, this is now our volume, the volume of the carbon dioxide at STP if you have 2.34 grams of it. So, when can we use ideal gas law equation? Again, we use ideal gas law equation if hindi constant or nagbabago yung mga variables such as yung pressure, temperature, and of course the amount of gas, and of course we will be using the universal gas constant. Yung universal gas constant naman, depende kung ano yung unit na ginamit mo sa mga given mo. Yun ang gamitin mong value ng universal gas constant. In our examples here, ang unit kasi natin ng ating mga pressure, temperature, and other given is naka liters for our volume, atmosphere naman for our pressure, for our temperature, it must be in Kelvin all the time, and of course, the amount of gas is in moles. So, kanina, nag-convert pa tayo ng grams to moles.